Let's take a look at an example of how to find the horizontal and vertical tangents to a parametric curve. Here we are asked to find all values of t at which the parametric curve given by x equals 2 sine t and y equals 4 cosine t has a horizontal tangent line and a vertical tangent line on the interval 0 to 2 pi. You could go ahead and graph this on your graphing calculator. Of course, you must be in parametric mode to do so. And if you graph it, you will find the graph looks like this. Now, it might depend upon what window you use, depending upon how you went about creating your graph. You might have only that right side of that oval. I believe when I did this, I did my x's as negative 2 pi to positive 2 pi. So this is the figure we're dealing with, and if you just take a look at it, you can tell there should be two locations at which we have horizontal tangent lines at the top and bottom of the oval, and there should be two locations at which we have vertical tangent lines here on the right and then over on the left. So that's what we'll be looking for as we work through this problem. Recall that a horizontal tangent is going to occur where dy dt equals 0, but dx dt does not equal 0. You'll remember that the way in which we find the derivative of a parametrically defined function, dy dx would be equal to dy dt over dx dt. So there are two components that provide for us dy dt. If we're looking for a horizontal tangent, we know that's essentially where the numerator part, the dy dt, will equal 0. But at the same time, we know we cannot have 0 in the denominator, and that's why dx dt cannot equal 0. So let's go ahead and find for ourselves what dy dt and dx dt were based upon what we were given. Dy dt, when we take the derivative of 4 cosine t, ends up being negative 4 sine of t, and dx dt, remember we were given that x was equal to 2 sine t, dx dt will be 2 cosine t. So let's start by finding where it is that dy dt, the negative 4 sine t, is equal to 0, and we'll go ahead and get those answers, and then we'll just double check to make sure that at those values dx dt does not equal 0. Dividing both sides by negative 4, we simply have that sine of t is equal to 0. And if you think about your unit circle and the fact that we are on the interval from 0 to 2 pi, t is going to equal 0 and then pi over on the left side of the unit circle, and then 2 pi, which of course is really the same location as 0. Now if we consider these values in dx dt, we have to double check that if we substitute these in, we don't get 0. So 2 cosine 0, remember cosine of 0 is going to be 1, so that gives us a dx dt value of 2. Same would be true for 2 pi. If t equals pi, we have 2 cosine pi, and of course cosine of pi is negative 1, so we have a negative 2 for that value. So we're good to go, and these would be the locations of our horizontal tangents. To find the location of the vertical tangents, we're going to do something similar, but remember that vertical tangents will occur where the slope is undefined, meaning that the denominator, which in this case was dx dt, that is going to equal 0. But at the same time, we then cannot have 0 in the numerator, because otherwise we have an indeterminate form in 0 over 0, and that's a whole other story. So we do need to double check that dy dt will not equal 0. So we're going to take that which we had for dx dt, the 2 cosine t, we'll simply set that equal to 0, divide both sides by 2. So if you again think of your unit circle and where it is that cosine is equal to 0, that's going to be at the top of the unit circle at pi over 2, and then also again at the bottom at 3 pi over 2. Now we do need to double check to make sure that dy dt does not equal 0 at those locations. So if we substitute in pi over 2 first, sine of pi over 2 is 1, so negative 4 times 1 is negative 4, so that one's okay. Sine of 3 pi over 2, upon substituting that in, is -1. So that yields a positive 4 for dy dt. So once again, these are okay. If you return to your graphing calculator, remember that you can use your second calc menu, and that first option will be value. And you can check out all of these values on your calculator. You'll notice that over here, this is pi over 2. I would recommend doing value at pi over 2, and it will take you right to the point on the curve. Over here on the left is 3 pi over 2. At the top we have 0 and 2 pi. Remember, they're the same location. And then down here at the bottom we would have pi. So you can use your graphing calculator to easily confirm that these are the locations at which we do have vertical and horizontal tangents.